Welcome to this explainer. Today, we're taking a raw study guide and transforming it into your absolute ultimate strategic interview playbook for full-stack Java roles. Look, if you're aiming to land a senior engineering position, you know the technical interview is a grueling gauntlet. So, we're taking actual interview questions and battle-tested answers from our source material and structuring them logically. By the end of this, you'll have internalized exactly what hiring managers are desperately looking for.
Okay, let's dive right into it. Tell me about yourself. We have all been there, right? It is literally the most universal, anxiety-inducing interview question on the planet. But it instantly sets the stage for our entire playbook. How you answer this single open-ended prompt dictates the flow of the entire conversation. You definitely don't want to just ramble about your work history. Instead, you want to present a highly engineered, professional summary.
So to get you there, here's our agenda for today. We'll cover 1. The personal introduction, 2. Explaining past projects, 3. Agile and architecture, 4. Core Java principles, and finally, 5. Advanced Java mechanics.
Let's start with Section 1, the personal introduction, perfecting the pitch.
You want to project the ideal profile here, a perfectly balanced developer handling everything from React to Kubernetes. Confidently state your 8 to 9 years of experience, but please, don't just say, "I code in Java." Break your expertise down into 3 distinct pillars. Mention back-end with Java and Spring Boot, front-end with React or Angular, and infrastructure using Docker, Kubernetes, and AWS. This shows them you own the entire lifecycle.
Moving right along to Section 2, explaining past projects, tailoring the domain.
Listen, you absolutely must tailor your project highlights to the specific domain. Are you interviewing at a bank? Well, talk financial data. Reference platforms like Wells Fargo Money Movement, MasterCard integrations, or evaluating vendor risk with Dun & Bradstreet scoring. But hey, if you're targeting healthcare, you got to pivot. Talk about Optum, automating claim settlements, prescription refills, and safe government integrations. The microservices under the hood, they might be exactly the same, but your business framing must absolutely match the room you're in.
Next up, Section 3, Agile and architecture, workflow and design.
Interviewers want to know exactly how you operate on a random Tuesday afternoon. You need to establish that you completely master the bi-weekly sprint lifecycle. You start by gathering business requirements, translating those into Jira user stories, because we all just love writing those, right? And getting to development. But do not stop there. Emphasize that you hit a strict 90% code coverage metric with your tests, move to user acceptance testing, and finally execute a live demo before production. This proves you're a disciplined engineer, not just some rogue coder.
Now, often they're going to throw a system design question at you. Say you're asked to design a shopping cart. You should propose a perfectly loosely coupled microservices architecture. Break it down layer by layer. For the front end, confidently choose React.js. Its virtual DOM allows for incredibly fast development. For the back end, propose Spring Boot for RESTful microservices, specifically name-drop in the embedded Tomcat server and JPA for database connectivity. And never ever forget security. Specify OAuth 2 as your standard authentication pattern. It's clean, it's modern, and it's exactly what enterprise teams are using right now.
And when they ask you about changing core logic, always mention performing an impact analysis across workspaces to avoid breaking dependent systems. It is not a trivial task to change a module that other teams rely on. Drop some specific operational details here. Mention using Eclipse shortcuts like Control-Shift-G to search for references, or doing a find in files across repositories using Notepad++. This shows them you actually think about the blast radius of your code changes before you ever press save.
All right, Section 4, Core Java Principles, the fundamentals. Let's get into the technical gauntlet.
You need to be able to fire off these 4 object-oriented principles without a single second of hesitation. These are the building blocks of literally everything you do in Java, and stumbling here is a massive red flag. So let's break them down exactly how you should explain them in the room.
First up is inheritance. Simply put, this is about extending existing classes without modifying them. It allows a new object to acquire the fields and methods of a base class. It's the ultimate tool for code reusability and adding new features cleanly.
Next is abstraction. This is where you rely on abstract classes in interfaces to hide the really complex implementation details from the user. It separates the ideas from the specific instances, exposing only the necessary interface. And remember, in Java, you might actually prefer an abstract class over an interface in time-critical applications because it's slightly faster. But an interface allows a class to have multiple behaviors at once, since Java doesn't support multiple inheritance of classes.
Then we have encapsulation. Think of this as putting up guardrails. It protects internal states and prevents objects from interacting in undesired ways. By hiding attributes, you dramatically increase usability and make code so much easier to maintain, simply because an object's behavior can be changed independently without crashing the rest of the application.
Finally, polymorphism. This is the ability of an object to take on many forms. And this directly leads us to our next crucial comparison regarding how methods behave, because polymorphism happens in two distinct ways, at compile time and at runtime.
Write this down because this is a guaranteed interview question. Overloading is compile-time polymorphism. You have the exact same method name, but different arguments, living within a single class. Overwriting, on the other hand, is runtime polymorphism. This happens within an inheritance structure where a child class provides a specific implementation of a parent's method. And always mention using the override annotation to ensure safety.
Finally, Section 5, Advanced Java Mechanics, Under the Hood.
This is where you separate yourself from the junior developers. You must clearly articulate when to use string builder versus string buffer. In Java, standard strings are immutable meaning. Manipulating them eats up resources. String buffer and string builder fix this because they are mutable. But here is the critical catch. String buffer is synchronized, so it's thread safe. String builder is not thread safe. But because it completely lacks that synchronization overhead, it is significantly faster in single-threaded environments.
Here's another deep dive. You will inevitably be asked how a hash map works. So, you must start strong by stating it relies on the principle of hashing to store its key value pairs.
But don't just stop at the textbook definition. Be prepared to break it down into these three specific internal components to show you truly understand the underlying data structure. Explain that the hash function is the native hash code method present in the object class. The hash value is the actual integer that method returns, and the bucket is where the key value pairs are stored. Actually, you must point out that in a hash map, a bucket is simply a linked list.
Moving over to stability, make sure you categorize your exceptions correctly. Errors, like an out-of-memory error, are out-of-scope JVM crashes. You can't do much there. Checked exceptions, like a file not found exception, are anticipated hurdles you must catch and log. And runtime exceptions? Well, frankly, that's just bad programming, like forgetting to check an array's length. Oh, and here's a pro tip for you. If they ask what happens if an exception is thrown from a finally block and isn't caught, the program simply exits.
As we near the end of the technical questions, always highlight your knowledge of modern Java 8 features. Mention the Stream API, the Date API, generics, which are great because they prevent class cast exceptions at runtime. And specifically, this really elegant Lambda expression syntax for anonymous functions. Explain that it takes an argument list, an arrow token, and a body block, which dramatically cleans up your code by removing all that bulky boilerplate.
So we've completely deconstructed the ideal experience pitch, domain-specific framing, architecture choices, and those tricky underlying mechanics. You now have the blueprint of a perfect interview response. Take these frameworks and fill in your own specific project details. But before you do, ask yourself a question. Looking at this entire playbook, what is the single weakest link in your tech stack right now, and exactly how are you going to fix it before you walk into that interview room?